Hello class, this is Building Construction for the Fire Service. This is Chapter 5, Fire Behavior and Building Construction. This chapter reviews the basics of fire behavior, explains how a building and its components influence a fire, explores how interior materials affect fire growth, spread, and describes the hazards of smoke and smoke behavior. The objectives we're going to cover in this chapter are as follows. We will identify fundamentals of fire behavior and key fire phenomena, describe the development of a compartment fire, identify the ways a fire is influenced by a building and its characteristics. We will also list the ways buildings and their components are affected by fire, explain how specific building materials behave under fire conditions and attack, and describe smoke behavior and the effects that it can have on the building, occupants, and firefighters. Fire requires 4 essential elements. In terms of fuel is defined as material that will sustain combustion and is called a reducing agent. Oxidizing agent is atmospheric oxygen or chemical compounds that release oxygen. Heat is a form of energy that is the source of ignition. An uninhibited chemical chain reaction is sustained oxidation reaction that produces sufficient excess heat to continue heating unburned fuel. There are 3 methods of heat transfer. Conduction, which is the transfer of heat within an object or between objects through direct contact. Convection, which is a transfer of heat through circulation within a medium such as a gas or liquid. And radiation, which is a transfer of heat through electromagnetic waves. Autoignition occurs when a combustible material ignites spontaneously without application of a flame or spark. Autoexposure is the vertical spread of a fire on the exterior of a multi-story building from one floor to floor or floors above. Now let's talk about compartment fires. A compartment is the enclosure around a fire, and there are 4 stages of a fire. The incipient, which is the initial stage after ignition. Free burning is the secondary stage in which the fire spreads to adjacent combustible materials. Flashover is the transition stage in which exposed surfaces ignite simultaneously and the fire spreads exponentially. Smoldering and decay is the stage in which glowing combustion takes place without flame. Think of it as when your charcoal burns down your grill, you're just left with embers and they kind of smoke. That's smoldering and decay, glowing combustion. Some elements of a compartment fire include a fire plume or column of flames, smoke, heated gases, and a ceiling layer, which are hot, buoyant gases at the very top of a room. The neutral plane is the interface between the hot ceiling layer and the cooler air flowing into the compartment. Entrainment is the process of oxygen being drawn into a fire. Flameover occurs when hot, unburned fuel gases at the ceiling layer suddenly ignite. Oxygen supply affects how much a fire burns and grows. Wind-driven fires exceeding 10 to 20 miles an hour must be considered tactically. And then there's always a fire blanket where you can attempt to snuff out any oxygen supply. Construction factors influence fire behavior is what we're going to talk about now. These construction factors influence various materials such as combustible interior finishes or walls, vertical openings, the height of the fire room, proximity of walls to each other, HVAC systems, and then remember also that the fire has effect on the overall building as well. Try to assess the construction technique, fire severity, and the fire duration to anticipate collapse. Fire affects all construction materials negatively, some more than others. Now we'll discuss backdraft. This is the burning of heated gaseous products when oxygen is introduced into an environment whose oxygen supply has been depleted due to fire. Hazards in addition to collapse are flashover, backdraft, concealed fires, and rigid spread of fire. Fire training schools may overlook hidden fire hazards. Hidden hazards and collapse should always be covered in the classroom. Ventilation can both limit risks and expose firefighters to other dangers. All abnormal situations warrant a thorough investigation, so use care when encountering unusual heat, smoke, or burning, and always make sure you do additional fire research. Growth and spread are influenced by building construction. Fire growth and flame spread are still not perfectly understood. Combustible acoustical tile, the fiberboard into which holes have been punched, may increase fire hazard. Here's some examples of fire growth and spread. Rapid fire growth is responsible for serious losses of life. When combustible ceiling tiles are suspended below the floor above, they create a void in which explosive carbon monoxide gas can be generated and stored. Ignition of trapped carbon monoxide gas produces a violent explosion. Now let's talk about building or content hazard. Fire growth building problems can be hidden or exposed. Fire growth contents problems can be due to furnishings, interior finish, decorations, or mercantile stock. One material may fall into different categories. High flame spread materials may contribute to both fire growth and generation of smoke and toxic products. Then there are always hidden building elements. Batt insulation has a paper vapor seal that leads to a phenomenal rate of flame spread. Sprinklers may not reach a fire spreading above the ceiling. Combustible fiberboard is commonly used as insulation sheathing. Foam plastic insulation has been involved in disastrous fires and should be protected from flame exposure with a 1/2-inch gypsum board covering. It can be manufactured to reduce flame spread, but will still melt. Electrical insulation also may be self-extinguishing. In terms of interior finishes, you have plaster, embossed steel, tin ceilings, and wooden boards or matchboarding, and these were all finishes used at one time and still exist in many buildings. Plaster does not contribute to a fire. Interior finishes may increase a fire hazard via increasing fire extension by surface flame spread, generating smoke and toxic gases, contributing to flashover by adding fuel, and low-density fiberboard is made of wood particles or sugar cane or bagasse. It's a cheap interior finish, quick installation. It's manufactured by Celotex, and when concealed in walls, it can be ignited by a plumber's torch. Now, I mentioned combustible acoustical tile, and this may be installed over the original ceiling with a void in between the ceiling and the tile layer itself. Industry opposition to regulation of interior finishes exists, and the NFPA, is in opposition to the use of fiberboard. Other hazards associated with interior finishes include adhesives, which can contribute to flame spread. They're used in a variety of applications in building construction. And then in regards to high density fiberboard, testing it with a blowtorch is inadequate, but punched with holes, it is called a pegboard. And then there's always paper, lots of paper, usually lying around. When talking about fabrics, you have cork, and the possibility of flames spreading faster than sprinklers can operate is often undervalued in terms of cork. And then you can have rattan and wood interior finishes. Plastics may be disguised as wood or glass. An example here is Ireland's Tribunal of Inquiry. Architects may not recognize potential combustion hazards and problems. This is something you need to read a little more about. The Worcester Cold Storage Warehouse fire in 1999 involved carpeting, and it's now used on the walls and ceilings. Used carpeting on walls is very, very dangerous, but there are a lot of old buildings out there with it. Now let's talk about void spaces. We've mentioned them a couple of times. Suspended ceilings of combustible tile form these void spaces. They contribute to flame spread and sometimes are remodeled ceiling hazards. In other words, they hung a suspended ceiling below an original ceiling. Building codes require installation of a new ceiling that must meet flame spread requirements. Removal of old ceilings is not required. Now let's talk about additional hazards. Aircraft interiors are one example we're going to use because the seats and interior fittings create fuel for a fire in an airplane. Aircraft built after 1990 have to meet stricter Federal Aviation Administration or FAA standards for fire and heat resistance. Then you have to consider acoustical treatment. Installations have been made without regard for flame spread of the materials used. And then you will encounter an open plan office. Open plan offices create a potential hazard. The need for corridors should be re-examined by code writing groups. With regard to alterations, you need to make sure that pertinent codes are obeyed and decorations and contents are within safety parameters, because they can produce major fire hazards, including Christmas trees. And there are few applicable regulations that exist. Regulations that do not exist are difficult to enforce. Haunted houses can be extremely hazardous. Glass fiber reinforced plastic is combustible despite the quote-unquote glass in its name. Fire loads and rates of heat release are greater today than when fire codes were first written. The nature of furniture and contents has changed over the years, but bear in mind, many buildings use older furnishings. The first interstate bank fire was in Los Angeles, and the NIST report on this fire should be copied and discussed. Please make sure to read more about it. In terms of hotel remodeling, you often encounter plastic furniture, mattresses, and carpets that may be inappropriately stored. And in terms of regulations, in the state of California, there are a tremendous amount of regulations, and the city of Boston, and also including the Port Authority of New York and New Jersey. With certification of interior designers, New York State candidates must take 2 examinations. One is interior design, and that includes building codes for fire and safety, residential fire tests, and also the report on NBS 1980 residential fire tests should be read. Information on test 14 was revealing concerning a test room full of furniture. And there are available films. You have the NFPA movies, most of which are on YouTube. And then you have Fire Countdown to Disaster is one film, and Firepower is another one of those films by the NFPA. Now let's discuss the elimination of high flame spread surfaces. U.S. merchant ship rules limit combustibility of construction materials and surface finishes. They separate the material from the source of combustion. Fluorescent light fixtures were recessed into combustible ceiling tiles at naval facilities. And then also what has to be done is a cutoff of the extension. In other words, you separate flammable from less flammable materials. And then coat the material. Fire retardant surface coatings are effective only if they are applied as specified, and they must be maintained. Instruminescent paints are used in and around the U.S. Capitol. Then there are pressure treated fire retardant wood, which is a good substitute where a wood surface is desired. And plastics can be manufactured to be more flame resistant now. In terms of smoke, the generic term to describe the airborne solid and liquid particulates produced by fire is smoke. There are solid particles in it that give it opaqueness, liquid particles that induce acrolein and halogen acids, and materials include carbon monoxide, hydrogen cyanide, and carbon dioxide. Smoke can do more damage to a property than fire or water. Now let's talk about some of these products of combustion. First is smoke gases. These can cause injury or death when inhaled or absorbed, and the toxic effect of concentration is a product of concentration and exposure time. The 1929 Cleveland Clinic fire involved nitrocellulose X-ray film. It really burned. And also it included, or older materials include polyvinyl chloride or PVC, which emits toxic gases when burned. There used to be, in the late 70s and into the 80s, there was a large use of PVC piping rather than copper piping. And if a building that has PVC piping, most of which has been replaced by now, but not all of it, emits toxic gases when it's burned. Now let's talk about gas flammability. Carbon monoxide is a flammable gas. It may ignite when sufficient oxygen is available. Carbon monoxide combustion can lead to flashover or backdraft. Gases can accumulate in any enclosed area. Ventilation of a building does not prevent carbon monoxide explosions. Now let's cover the physical effects of smoke. Particulates and gases have different physical effects on people. Carbon monoxide is colorless, odorless, and tasteless. Smoke particles can plug up screens, preventing air filtering. Smoke damage may be the most expensive byproduct of a fire. It contains contaminated and toxic smoke. Smoke may be contaminated with radioactive material or another health hazard substance like polychlorinated biphenyl or PCB, and the cost of a cleanup may be higher than the cost of the fire damage itself. It may be less expensive to ultimately abandon a property rather than try to clean it up. The largest example in the world is the nuclear power plant in Hanford, Washington. It obviously cannot be abandoned, but it is the largest toxic cleanup site on Earth. The toxic effect of PCBs is also a threat to firefighters. Now let's discuss corrosion. Plastics containing halogens from corrosive acids when combined with hydrogen and oxygen or moistures in the air. And with smoke movement, remember that fire gases rise due to buoyancy. Smoke may cool and remain in the building even after the fire is out. Now, in summary, these are the points we covered in this chapter. We discussed how understanding fire behavior, including the effects and hazards posed by heat transfer, is critical for all firefighters and can influence tactical decision making. While component fires are complex and dynamic, fundamental aspects of the combustion process can be identified and understood. The most important factor is often the oxygen supply, which is the location and quantity of oxygen needed to feed the fire, and that will dictate how the fire burns and grows. We also discussed that fire behavior is influenced by building construction, and buildings can be negatively affected by fire in a variety of ways, including the materials lining the walls and ceilings of the space. Firefighters are at great risk from rapid fire growth, especially where there is a lack of communication between fire prevention and fire suppression personnel. In addition to fire growth, high flame spread materials may contribute heavily to the fire load and to the generation of smoke and toxic products. There are several possible approaches to control the problem of fast fire growth, including eliminating high flame spread surfaces, separating material from the source or sources of combustion, cutting off the extension of the fire, and maintaining the materials and coating the materials, And finally, we talked about smoke, and smoke is a generic term used to describe the collective group of solid and liquid particulates and gases. Smoke can affect occupants, firefighters, and buildings in many ways and may well be the most expensive byproduct of a fire. Okay, class, that's it for Chapter 5. As always, thank you for all of your time, and hopefully the attention you gave this will help you in terms of supplement work for your textbook itself. As always, make sure to consult your instructor if you have any questions. Thank you again.